Okay, so good morning. Uh, till now, what we have seen unit number 2. We have completed all the part of unit number 2. So in that we have seen the response of the system for different input standard test signals, as well as we have seen what is the steady state error. I have given the assignment on unit number 2. So there are a lot of difficulties in solving the assignments. So for that, what I have done, I will take some problems which will help you to utilize your concept and analyze the system. So I will take the problem on time domain analysis, right, as well as steady state error, and by understanding these problems, right, you will be able to solve the assignments, right, as well as you will able to analyze the system. So let us take some problems. So let us start with problem number 1. So what is this problem? The question is for a system whose g of s is 20 upon s square plus 5s plus 4, right? So this is a control system and it is having a unity feedback. With unity feedback, we need to find the time domain specifications when the unit input is applied, right? So what is given? Feedback is also given, and what is the input, that is also given, and this is the system, right? So here the feedback is unity, so output is directly connected to input, right? So this is your negative feedback system and this is your g of s, right? So what is the closed loop transfer function? So okay, let us find the transfer function for this. So this will be g upon 1 plus gh, right? So this is your transfer function. So now what we need to do, we need to find the time domain specification. So for that, if you observe the transfer function, in the denominator it is a quadratic equation in S, right? So highest power of S is 2. So we have done the analysis of second order system. So in the second order system, we will compare with the standard denominator, that is s square plus 2 zeta omega ns plus omega n square, right? So if you compare, omega n square will be equal to 24, right? Then so therefore omega n will be root of 24, that is 4.89 radians per second. Similarly, 2 zeta omega n value is equal to 5s, right? So 2 zeta omega n is equal to 5s, so we get the value of zeta, that is 0.5112. Okay. So what is your damping frequency, omega d? Omega d is nothing but omega n root of 1 minus zeta square. So that comes out to be 4.203 radians per second. And once we get the value of omega n zeta, we can get all the time domain specifications, right? So let us find first, this is your peak time. So formula for peak time is pi by omega d. Just substitute the value of omega d from here and you will get a TP as 0.747 seconds, right? Similarly, TR, right? So TR is rise time. Again, we know that TR is nothing but pi minus phi by omega d. What is phi? Phi was, we know that triangle. So from that, phi is nothing but tan inverse of root of 1 minus zeta square by zeta. So that comes out to be 1.034, right? So this will be in radians. So just substitute the value here, you will get the value of rise time. So it will be pi minus 3.14 minus 1.034 divided by omega d, that is 4.203. So the rise time is 0.501 seconds, right? Similarly, we can find the TD. TD is 1 plus 0.7 zeta omega n. So substitute the value of zeta and omega n, right? All are formula based, right? So if you substitute the value of zeta and omega n, it comes out to be 0.277 seconds, right? Then two parameters are remaining, that is your MP, peak overshoot. So that will be percent MP, right? Because I am multiplying it by 100. So 100 into e raised to minus zeta pi divided by root of 1 minus zeta square. You just substitute the value and then it comes out to be 15.43 seconds. And finally, this is your settling time. So settling time will be 4 times t. T is your time constant, that is your 1 by zeta omega n. So 4 by zeta omega n, that will be 1.601 seconds, right? So like this, once you get the value of zeta and omega n, we can find all the 5 time domain specifications by using respective formulas TP, TR, TD, MP and TS, right? So this was a basic question which will give us an idea that how to analyze the system in time domain. Now see here, for time domains, whenever we are having, we have been asked to calculate this time domain specifications, right? we will be given a second order system, right? So always compare the denominator with the standard denominator and fetch out the value of omega n and zeta, and once you get the value of omega and zeta, you can find out the other parameters, right? So this next question is slightly modified question, right? So directly if a system is not given, how to tackle that problem? So let us see this in second problem. So the second problem deals with that. The question is, the system equation is given by d2y by dt square plus 4dy by dt plus 8y is equal to 8x. So this is the differential equation, right? And find the time domain specifications for unit step, right? Okay, so your unit step signal is applied as an input. Now see, this is the differential equation of the system, and in the introductory lecture of the transfer function, we have seen how to find the transfer function by using the differential equation, right? So this is the given differential equation. Right here it is mentioned that x is input and y is output. So by basic definition of the transfer function, what is transfer function? It is Laplace transform of output to the Laplace transform of input with zero initial conditions, right? So see, this is your differential equation. Now we will take the Laplace transform, right? This will be in time domain because we are differentiating with respect to time, right? So let's convert into S domain, Laplace domain, by taking the Laplace transform of the above differential equation. So consider the Laplace transform of y is y of s. Consider the Laplace transform of x is x of s. And then we know d2y by dt square. If it is d2 by dt square, this is your second order term. So it will be multiplied by s square. So it will be s square into Laplace transform of y will be y of s. Plus similarly 4 will be as it is. Dy by dt will be s into y of s plus 8 as it is y of s, right, is equal to 8 into Laplace transform of x is x of s. Now what we want output by input, means what? Y of s divided by x of s. So from this equation we can find out, we can separate out the terms of y of x, y of s we can take common, and then y of x s divided by x of s will be equal to 8 divided by s square plus 4s plus 8. So this is your transfer function of the system. Once you get the transfer function, it's very simple, right? So this is the transfer function. Just observe the denominator. Denominator is a quadratic equation, right? Or we can say second order system, right? So if we compare with the standard transfer function, it will be s square plus 2 zeta omega n s plus omega n square. So here omega n square will be equal to 8 and 2 zeta omega n will be equal to 4. So from this comparison we can get the value of omega n. Similarly we can get the value of zeta and similarly omega d. Like in the previous problem, once we get the value of omega n and zeta, we can find happily the other parameters like td, tr, tp, mp and ts by using our regular formula, right? So td, let's calculate td. Td will be 1 plus 0.7 zeta by omega n, that comes out to be 0.5285 seconds, right? Similarly tr, rise time will be pi minus pi by omega d. Just substitute the value of pi will be tan inverse of root of 1 minus zeta square by zeta, and then we know the value of zeta, we know the value of omega d. Just substitute the value of zeta and omega d and calculate, we will get the rise time as 1.178 seconds, right? So what you need to do, you need to take the pen and paper and you need to substitute the value, use the calculator and just verify whether you are getting the correct answers or not, right? That will make you feel comfortable, and that will, you can get practice of these things, right? Similarly we can find the value of tp, mp as well as t of s, right? Okay, so these parameters are, you can write it down. Okay, similarly what is the question, right? He is saying that find the time domain specifications for unit step. So we have find the time domain specifications, right? Now let us see what is the response of the system, right? Response of the system, the second order system, this is proven formula. We have derived this equation, that is c of t is equal to 1 minus e raised to minus zeta omega nt divided by root of 1 minus zeta square into sine of omega dt plus phi. So we know the value of zeta, we know the value of omega n, we know the value of omega d, as well as we know the value of phi. So finally if someone asks you that what is the response of the second order system, just write this formula and substitute the values. You will get 1 minus 1.41 e raised to minus 2t sine of 2t plus 0.7853. So phi, I have taken the value of phi from here, right? We have calculated this phi, as well as we know all these values, zeta we know, omega n we know, again here zeta we know. So just simplify this and you will get this equation. So what is this equation finally? This is the equation of C of t. So C of t for this system, the response of the above system, right, is this, right? So you get a mathematical formula of response of the system. This is a generalized formula and this is a very specific formula for the above given system, right? So like that we can find out the mathematical formula and mathematical relation of what is the input and what output we will get, right? So this was one more type from this second order system. Now let us wind up this lecture with a again a modified problem, right? The problem is the question is very simple, but the way of asking is somewhat different, right? So in this question, what is asked? Measurement conducted on servo mechanism shows that the system response to be C of t, right? So a servo mechanism system is there, control system. So the response of this servo mechanism control system is given by C of t is equal to 1 plus 0.2 e raised to minus 60t minus 1.2 e raised to minus 10t, right? This is the response when this system was subjected to a unit step, right? So input was unit step. Now what he is asking, obtain the expression for closed loop transfer function, right? Means what we need to find? We need to find the transfer function and find the time domain specifications, right? So time domain specifications, once you get the transfer function, you can easily find the time domain specifications, right? So what is transfer function? We need C of s by R of s, right? C of t we have, right? So can we find C of s? Yes, by taking the Laplace transform we can get the C of s, right? So Laplace transform of 1 is 1 by s, 0.2 as it is e raised to minus 60t, Laplace transform is 0.2 divided by s plus 60 minus 1.2 as it is e raised to minus 10t, Laplace transform is 1 upon s plus 10. So this is your C of s. Now input was R of t. So R of t was your unit step, so U of t. So taking again Laplace transform, R of s was 1 by s, right? Laplace transform for unit step function is 1 by s. So your closed loop transfer function is C of s by R of s. Just I will substitute the value of C of s divided by R of s and then I will simplify it, right? Cross multiply and simplify. You will get that closed loop transfer function to be 600 divided by s square plus 70s plus 600. And then you observe, what is this? This is the transfer function of the above system, and from this transfer function we can conclude that the above system is your second order system. So once we get the second order system, we can compare it with the standard denominator s square plus 2 zeta omega n s plus omega n square, and from here you get the value of omega n square is equal to 600 and 2 zeta omega n is equal to 70. You get the value of omega n and then you get the value of zeta. So once you get the value of omega n, once you get the value of zeta, then you can find out what is the value of omega d, tp, tr, ts, mp and all the time domain specifications, right? All the parameters you can find it out, right? So this is your homework. You just have to solve this problem completely. So this was the problem on your time domain specifications. Let us see in another lecture the problems on your error, steady state errors, right? Okay, so hope you are getting the concepts. So using these concepts, complete your assignments. Thank you.